everyone, welcome back to Mihinsara Tech. In today's video, we are diving into one of the classic problems in computer science, the Tower of Hanoi. If you are learning data structure and algorithm, it is a must-know concept. So let's break it down step by step. What is Tower of Hanoi? The Tower of Hanoi is a mathematical puzzle involving 3 rods and a number of disks of different sizes. The puzzle starts with all the disks neatly stacked on one rod in decreasing size, the largest at the bottom and the smallest on top. The goal is you move the entire stack to another rod, obeying 3 simple rules. When solving the Hanoi puzzle, there are simple 3 rules. The first one is you can only move one disk at a time. Rule number 2, a large disk cannot be placed on top of a smaller disk. This ensures the puzzle maintains a logical and increasing order from top to bottom. Only the top disk of any stack can be moved. You cannot move a disk that has other disks on top. Besides being a fun brain teaser, the Tower of Hanoi is important because it helps us understand recursion, algorithmic thinking, and problem-solving strategies used in computer science. Now, here's something cool. If you have n number of disks, the minimum number of moves needed to solve the Tower of Hanoi is 2 to the power n minus 1. For an example, if we have 3 disks, it should be 2 to the power 3 minus 1. That is 7. So, the minimum moves for 3 disks is 7. So now let's solve this puzzle in 7 moves. Can anyone guess? Let's do it. Count with me. 1, 2, 3, 4, 5, 6, 7. This exponential growth means the problem gets complex quickly as n increases. The Tower of Hanoi is a classic example of recursive problem. Here's how the recursive strategy works for n number of disks. Now let me explain something. Each of these rods have a name. For example, this rod has disks and I want all 3 of these disks to move into this rod. This rod is known as a destination rod and this rod is known as a source rod. And the rod we get help to move from the source rod to the destination rod is called the auxiliary rod. Now, if the disks were in this rod, this is known as a source rod. If the disks were in this rod, this is known as a source rod. And if this is the destination, this is the auxiliary rod in this problem. Each of those steps is a smaller version of the same problem. You might be wondering, is Tower of Hanoi just a puzzle? Well, its concepts are used in recursive algorithm designs, file system backups, memory allocations in operating systems, even in artificial intelligence planning. If you found this helpful, give a thumbs up, subscribe to Mihinsara Tech and hit the bell icon so you will never miss an update. Thanks for watching, and I'll see you in the next video. God bless and have a great day.